Hey everybody, I want to go over some velocity versus time graph trends, talk acceleration a little bit, show you what some of that looks like on a graph. Then we can come up with an infographic that will kind of clarify some of these trends and maybe talk about some tips on reading those trends. So I want to start by showing you a few trends using the SmartCart. So just to clarify, this is going to be forward, this is going to be reverse. So I'm going to start by showing you what that looks like in terms of going forward. So forward velocity, forward constant velocity, and when we say constant velocity, velocity is not changing. We have no acceleration. So I'm going to try to make this as constant as possible, and well, we'll see what we end up with. So I'm going to move it, hopefully keeping a constant velocity, and not bad. So we get a relatively flat line, and we see that that line is located above the x-axis or the y=0 line, and that tells us it has a positive velocity. Positive means it's moving forward. So now let's take a look at what that would look like going backwards at a constant velocity, and then we can compare the two. So I'll start this and try to hold a constant velocity in reverse. All right, so we see that we have, again, a flat line, but this time the line is located below that y=0 or the x-axis origin line because, well, our velocity is negative. Now, again, I want to stress that negative doesn't mean it's less than any positive value. Negative simply tells you it's going in the opposite or reverse direction. So our first line was above that 0, which means it was a positive velocity. Our second line is below the 0, telling us it's a negative velocity. But you'll notice that the two lines are about equal distance from the 0, which means they were both traveling about the same speed, just in the opposite directions. So they had different velocities in that they had different directions, but in terms of their speed or their distance per unit of time, they were traveling at about the same speed. So again, try to get used to thinking about the positive, negative as direction and not simply, well, negative's less than positive and, you know, like you learned in math. Again, positive or negative tells you the direction. A couple other trends I want to talk about. I want to show you what it looks like when it is accelerating in the forward direction. So we're going to do another run. And so I'm going to start it, just let it sit here. It's at 0 velocity, and now I'm going to accelerate. And you'll notice that it goes up, showing us that our velocity is increasing. You'll also notice that the line is moving away from the 0, the x-axis or the y=0 line, meaning that we are increasing our value, our y value, which is increasing our velocity. The little kind of level off at the top is because I started to slow down before I hit the button, but for the most part, you can see that it is climbing away from that 0 mark. I want to show you now what it looks like when it accelerates in reverse. And so I'm going to start over here so I have more room. And so I'm going to let it sit for a second, and now I'm going to speed up backwards. And you can see that, well, we get this line that shoots away from the x-axis or the y=0, but it's going the other way. Again, it is negative. Negative does not mean it's less than positive. It just means it's in the other direction. So that line is moving away from the y=0 mark, meaning we are increasing our speed, but we are doing it in the reverse or negative direction. So our velocity is different than our last trial, shown here, because it's moving in the opposite direction. Otherwise, accelerations look approximately the same. The slope of these lines looks pretty close, meaning they're accelerating at the same rate, just our big difference is the direction they were doing it in. I want to show you what it looks like when they speed up and then slow down in the same direction. And this is where things get a little tricky. So let me do that first, and then we'll talk about the trend. So we're going to go forward, and then we're going to slow down back to 0. Okay, now a lot of times when students see a graph that looks like this, they think, oh, it went up and then it turned around and came back. But that's actually not the case. All we did was accelerate and then slow down. So, well, I should say we accelerated the whole time, but we sped up and then slowed down. And so we see that trend. We see the line moving up, meaning our velocity is increasing. And then right at the top of the curve there, it starts to go the other way. We have acceleration in the opposite direction of motion, meaning that we start to slow down. So while motion is still forward, we never went backwards. Acceleration went from positive to negative, meaning we went from speeding up to slowing down. And that's a pretty tricky one for a lot of students to see. A lot of times they think this is what's happening. And let me show you what that actually looks like, because it's very different than this one here. So we speed up and turn around and come right back, and yeah, that is a crazy looking graph, but it is showing what actually happened. Notice our velocity shoots up to about 1 meter per second, and then it drops significantly. That's where I turned around and started going, or I slowed down quite a bit. The line crosses that x-axis at velocity equals 0, and it becomes negative, and that's the exact point where I started going backwards. Okay, so that is very important to see and realize that it's really a key factor to really look at the graph, really look at the values of velocity, and that will tell you what direction it's moving in. So like I said, for this one, this is where it went up and right back. It's not what we saw where we sped up and then we slowed back down in the last trial, the green line. All right, let's take a look at some graph trends. So I have a velocity versus time graph here. I've included some key ideas. So again, positive and negative are referring to direction. So 3 meters per second positive and 3 meters per second negative. That's the same speed, just moving in a different direction. And so something to keep in mind that -3 is not less than +3. It just means it's in the opposite direction. So that's something you really need to make sure you focus on. Now looking at the graph, anything above the x-axis or positive is going to be a positive or forward velocity. And as you move away from the x-axis, that is increasing, increasing forward velocity. All right. And as you move away from the 0 or the x-axis in the negative direction, you are still increasing your velocity, but you are doing it backwards. So increasing backward velocity. So either way you move away from the 0 or the x-axis, you are increasing your velocity. It just depends on which direction you're doing so. And so again, making sure you're paying attention to those positives and negatives. Now, if the velocity at any given point is positive, again, that is forward motion. Sorry for all the pen marks here. So pretty much anything above the x-axis, so where I'm marking this blue area, is going to be, let's see if I can do this neat here, there we go, is going to be forward motion, okay? And you guessed it, anything below the x-axis here and below is going to be backwards motion. Whoops, that's not what I wanted to do. Let's try that one more time. So again, anything below the x-axis is going to be backwards motion. So where I'm marking the magenta or pink or whatever you want to call it here, anything below that x-axis, that y equals 0 mark, that is going to be reverse motion. Okay? All right, so I think we've got the trends there. And I do want to point out that for acceleration on this graph, again, we are going to calculate acceleration by calculating the slope. And you guys know from graphing that to get slope, it's the change in y over the change in x. And if you forget that that's acceleration, well, y is in meters per second, x is in seconds, and when you do meters per seconds, that gives you meters per second squared, which is our unit of acceleration. So again, acceleration can be calculated by finding the slope of the line at any given part of the graph. And so we'll point out some trends here. So I want to start by looking at the part of the graph here where time is 0 and velocity is 0. And let's look what happens between that and this point up here where time is 5 and velocity is 5. So I'm going to show the coordinates there. So my x-coordinate is 5, my velocity, my y-coordinate is 5, and I'm going to put a positive just because we are using positive, negative here for those. And so what happened? Well, we see that here we had at time 0 we had 0 velocity, and then the object started to change its velocity. It started to accelerate. It went from 0 velocity to a velocity of 5 plus 5 meters per second. And so between the first point and the second point here, we see that velocity changed by plus 5. And so what can we gather from that? Well, if we compare, if we look at our axis point, well, we see that that is a positive velocity. It is in the blue area, meaning we are traveling forward. And which direction did we accelerate? Well, let's do a quick calculation. I won't do it for each line, but I'll show you at least how this works. And so for that particular segment A, I'll do that down here, our change in y is going to be that positive 5 minus 0. And our change in x will be 5 minus 0. So we see that we have plus 5 meters, whoops, there we go, over 5 seconds, which gives us, sorry, that should be meters per second, which gives us a positive 1 meter per second squared. So on segment A, our acceleration is 1 meter per second squared. That's telling us that for every second that goes by, our velocity changes by 1 meter per second. And we can see that, right? Because, well, if we look at where we're at, after 1 second, our velocity is at 1. And after 2 seconds, our velocity is at 2. We add another second, we add another meter per second of velocity, and so on until we get to our 5 meters per second. So again, 1 meter per second squared is telling us that for every second that goes by, our velocity changes by plus 1 meters per second. All right, so now let's look at the next segment on the graph, and we can see here that we end up at a time of 9 and a velocity of plus 5. So our time changed, well, obviously, because time doesn't stop, and so time keeps ticking away, but our velocity didn't change. And so that tells us we have a constant velocity. And another way to figure that out is, well, we have a flat line, which means there's no slope, no acceleration, no change in velocity. We see that because our velocity is still positive 5. And so we can do that again, and we notice here now that the line is going down, back towards the 0. And again, if the line goes towards the 0, that means we are slowing down. Our velocity is approaching 0. So this point is going to be 10, 0. And so we had a change of negative 5 in this case. So we went from 5 to 0. So we changed our velocity by negative 5. And we did that in 1 second. So we actually have a pretty high acceleration of negative 5 meters per second squared. And that's kind of an important thing, because you'll notice at A, we had an acceleration of positive 1 meters per second. I'm going to label this B, and I'll show you the calculation. So B, we had a change of 0 minus 5 meters per second, and that happened over 1 second of time. Throw my units in there. So we have negative 5 meters per second squared. And that is an important thing because we have a negative acceleration. Does that mean we're going backwards? Well, let's take a look at the graph. Along this line, we are still up here above the x-axis, above y equals 0. We still have positive velocity along this line. Okay, so that is key. That's telling us we're still going forward, but it just means that we are accelerating in the opposite direction, so we are slowing down. Okay, when acceleration happens in the opposite direction of motion, we slow down. So if we throw some labels here, let me add for this part, And actually, well, that's probably going to mess that up here. All right, so I will say that here, motion, we have forward motion, and for acceleration, we have forward acceleration. Okay, now over here at B, a little bit different. Acceleration is now in the opposite direction. It's negative. Negative acceleration is in the opposite direction of positive. But our motion is still positive. It's still forward. Okay? So that means we're going to slow down. All right? So here we are slowing down. Here we are speeding up. Okay? So that's a pretty big concept to try to grasp. If acceleration is in the same direction of motion, you speed up. If acceleration is in the direction opposite of motion, you slow down. And you know what? If all else fails, go back to what you know. Look at the coordinates. If your velocity is going from 5 to 0, what did you have to do in your car to get it to do that? You had to hit the brakes. You had to slow down. Okay, to go from 5 to 0, you had to slow down. So that's another way to figure out what's going on with the motion of something. Alrighty, let's look at the next point down below the x-axis, or y equals 0. So we go from that 10, 0 coordinate. Here we are at 12 and -6. Okay, so our velocity changed from 0 to -6. Does that mean that it's less than any positive velocity? No, it just means that we sped up in the negative or reverse backwards direction. So now we are going 6 meters per second in the backward direction. And so does that mean that we have a speed up or a slow down? We sped up. Is our acceleration positive or negative? Well, if we calculate it, let's call that point C. And let me actually move this down here so that we can show that. So let's say this is segment C. So segment C, we have a change of y. We went, so our new y is -6, and our old y is 0. And that is meters per second. That's over a time of, new time of 12 seconds minus our old time of 10 seconds. So we get -6 meters per second over 2 seconds, which gives us a -3 meters per second squared acceleration. So we have negative acceleration, and we also have negative velocity. So in this particular case, velocity and acceleration are both, one second, in the backwards direction. And if they're both going in the same direction, that means you are speeding up. Okay? Alrighty. And if we look at the line next to that over here, without calculating, we can see that the slope of that line is positive. And so we can see that acceleration is now acting in the forward direction. Motion is still acting in the backwards direction. So they are not in the same direction, which means that we are slowing down. Okay, and we can also see that by looking at what our velocity is doing. Our velocity is going from this point here at -6 and ending up here at 0. So to go from a velocity of 6 meters per second backwards to 0 meters per second, we had to slow down. Okay, so I hope that helped clarify these graphs. I hope the trends are making a little more sense. If you do have any further questions, please feel free to ask. Send me an email, ask me in class, come by, set up an appointment to get some help, or post a comment. Thanks for watching. Have a good one.